Hello, you are welcome, our beloved esteemed viewers, once again to our favorite mathematics YouTube channel, Mathematics by Abu Zainab, a channel specially created for you and I to demystify mathematics and to tackle headlong once and for all the age-long phobia associated with this important subject. In our previous videos, we learned number-based conversions, how to convert from base 10 to other bases and from other bases back to base 10. We're taking it a step higher today by learning how to convert from bases that are not 10 to bases that are also not 10. I call that conversion from other bases to other bases. Come along and let's learn this interesting part of the topic. Conversion from other bases to other bases. Without wasting time, we go straight into examples to expatiate further what it's all about. So we convert 1011 base 2 to octal and 2 to AB base 16 to say duodecimal, and that's base 12. So in the summary, how this is going to pan out is this. As you can see, we are going from 2 to 8 and 16 to 12. Neither is 10 involved from the beginning and to the end. However, we can't do it without going through base 10 as a standard or default number base. Hence, we are going to go from 2 to 10 and then from 10 to 8. It's a two-step effect. Similarly, we are going to go from 16 to base 10 there and from base 10 then to duodecimal. So let's write along. So number 1, we have 1011 base 2 first to base 10. So that's going to go this way, 1011. We have 2, 2, 2, 2, 0, 1, 2, 3. So that's going to become 1 times 2 to the power of 3 plus, we need not write 0 because 0 times anything we are going to have 0 still. So we can move to 1 times 2 to the power of 1, then plus 1 times 2 to the power of 0. So 2 to the power of 3 is 8 times 1, 8, plus 2 to the power of 1 is 2 times 1, 2. 2 power 0 is 1 times 1, 1, making this 11 base 10. That is the first leg of the solution. Convert first to base 10. Then we go from that base 10 to the destination base, which is base 8. And how that operates is by division. 11 divided by the new base, which is 8. 8 in 11 is 1, remainder 3. 8 in 1, 0, remainder 1. So we have 1, 3, base 8. In conclusion, we can say that 1011 base 2 is equivalent in value to 13 in base 8. And that does it, which I believe is quite explicit and easy to understand. Let's now take the second example to see how it pans out. Now, the second example is pretty much the same idea. We first take 2AB in base 16 to base 10. That's the first leg. And that goes this way. 2AB. We got here 16, 16, 16, 0, 1, 2. And that is going to expand as 2 times 16 squared plus A times 16 to the power of 1, then plus B times 16 to the power of 0. Now, going further, 16 squared is 256. A common mistake you must try to avoid is to be tempted to multiply these 2 by 16 before squaring. No. What this means is 16 squared, because 16 squared is an operation on its own. So you have to first square this 16 before multiplying the answer by 2. So don't mistakenly say 2 times 16, 32, and square that. That would be obviously wrong. Take note of that. And in base 16, A is 10. A has value 10 times 16 raised to power 1, which is still 16. And B has a value 11. 16 to the power 0 is 1. Anything to the power of 0, by the way, is 1. So 2 times 256 is 512. And 10 by 16 is 160. And 11 by 1 is 11. On adding this up, we're going to have 683. 683. Of course, in base 10. Are we done? Not yet. This is just one half of the solution. The last half is to convert the 683 base 10 now to base 12, which is duodecimal. How that goes is this. We are going to have this 683. You divide by 12 because we are going to base 12. So 12 in 68 is 5, remainder 8. Then in 83, 12 in 83 is 6, which is 72, remainder 11. But we can't write 11 here because we are in base 16. Rather, we write what? B, which stands for 11. We go on. 12 in 56 is 4, because that's 48. Remainder 8. And 12 in 4, 0, remainder 4. And we end it there, thereby having 4, 8B, base 12. In other words, we can conclude by saying 2AB base 16 converted to base 12 is equivalent to 4,8B base 12. And that is pretty much the end of the solution of how to convert from other bases to other bases. In summary, we have been able to look today briefly at how to convert from bases that are not 10 to bases that are also not 10, other bases to other bases. And that pretty much does the achievement of today's objective. And I believe strongly that you do enjoy this class and found it exciting and interesting as I did. If you do, please do well to subscribe, watch, comment, view, and share. And don't forget to put on your notification button so that you'll be the first to know when next our video drops. And our next topic, God willing, shall be operations involving number bases, whereby we look at arranging bases in different form, be it ascending or descendingly. Thereafter, we look at radicals or square roots. Stay tuned and God bless. Thank you.